Okay, the first example, 13.1. Water at the temperature at 10 degrees C flow through a pipe of diameter D. Diameter is 1.85 centimeter into a glass, as shown in below figure. Okay, this is a temperature 10 and this diameter of the pipe. Okay, to the glass. And the question is to determine the minimum time to fill the 0.355 liter glass, okay, in case of the laminar flow. And we have to repeat again if the temperature increased to 60 degrees. So what is the minimum time? And the part B is what is the maximum time to fill the glass in case of the flow is turbulent flow. And repeat for the 60 degrees C. Okay. So for we going to apply Reynolds number. The number is the initial force divided by viscous force is dimensionless variable. It is equal to rho Vd mu or Vd over nu. Okay. We start first from the laminar flow. Laminar flow Reynolds number is about 2100. Okay. And next we substitute Reynolds with the rho Vd so we can find what is the velocity is equal to 2001 mu divided by rho d. Okay. And next we have to identify what is the mu and rho from the water property. In lecture 2, okay, we can find that at the T is equal to 10 degrees C, the density of water is equal to about 1000 kilogram per cubic meter, and the dynamic viscosity is 1.307 10 power minus 3 Newton sec per square meter. And at the T is equal to 60 degrees, density is lowered to 82.3, 83.2, and mu is equal to smaller to 4.665 10 power minus 4. Okay, so we can find the velocity from the substitute the viscosity and density in this equation. Convert to meter. For the laminar flow, the velocity is equal to 1.48 meter per second. Okay. And we have to find what is the Q. Q equal to VA equal to the volume divided by time. Now we can find that the time is equal to the volume divided by velocity and area. So for T is equal to volume is the volume of the glass, convert to cubic meter, divided by velocity and divided by area of the pipe. So the time is about 8.92 seconds. Okay, to fill up the glass. Okay, and we can repeat for temperature is 60. We can find that velocity is even smaller to 0.054 meter per second, and time is longer to 24.4 seconds. Okay. So in this case, we can say that is if at a high temperature, we will give the low kinematic viscosity and provide the low velocity and low Q, and finally give a high times. Okay. In this case, if you want to keep laminar, Q is decreased. Okay. The next question is if the flow is turbulent flow. Okay, so in this case, we have V is equal to 4,000 mu divided by rho d. And if you substitute rho and d for 10 degree, we can get V is equal to 0.28 meter per second. And T is equal to volume divided by the velocity, and area is, we got 4.67 seconds. That is for the 10 degree C. And at the, if increase to 60 degree C, we found that the velocity is smaller to 1.1. Okay, and T is 13 seconds. Okay, if we plot the curve, it means for the 10 hour, 10 degrees Celsius, we expect that the temperature is for the time to fill up the glass for laminar flow is about 8.9 minutes second, but for the turbulent is about 4.7 second. Okay, we discuss further to if we replace the water with honey. So honey, what is the viscosity of honey? For the kinetic viscosity for honey is greater than water, about 3,000 times. So we expect that velocity can be increased. And one is increased velocity, time can be reduced. With this proportion.